Assalamu alaikum, dear students. Again, Faisal Omar with you. Today we are going to start with the modern atomic theory and quantum numbers. Let's ask a question from you. Again, question? Yes, obviously. If you don't ask any question, no one will answer. So let's start with the question. That was my question. What do you think about the structure of atom? Do you still think that it's a kind of small, tiny ball, as Dalton told us, or as a kind of plum pudding, as J.J. Thomson told, or is a kind of solar system? Nucleus is inside the atom and electrons are orbiting around the nucleus. Let's have a look. The modern atomic theory is based upon the concept and idea of many scientists like Louis de Broglie, Erwin Schrödinger, Einstein, and Heisenberg. In modern atomic theory, there's a concept, wave-particle duality concept, which says that electrons behave like a wave around the nucleus. When electrons are orbiting around the nucleus and they have a wave motion, they produce an electron cloud around the nucleus. They are not circulating in a kind of neat planet-like orbits around the nucleus. So for right now, we say that this is correct. No, this is wrong. Okay. This is a kind of helium atoms example. You can see that there are two neutrons and two protons inside the nucleus of helium, and you see a cloud around the nucleus. This cloud is produced because of the motion of the wave motion of electrons around the nucleus, because electrons are moving around the nucleus billions of times in a second. So we cannot catch an electron around the nucleus, but we can observe the electron cloud around the nucleus. So in modern atomic theory, the finding of electron around the nucleus is based upon 4 quantum numbers. Okay, let's for this electron cloud, let me give you an example. Have you seen fan? Yes, we use fan in summer. When it gets hot, we use fan. You see that when fan revolves, you cannot see the individual wing of the fan. You can just have a look. You can just observe and cloud of the wings of the fan that are rotating around the nucleus of the fan. So it's something like this. Okay, so let me tell you about the 4 quantum numbers. Now we are going to study quantum numbers. You have a question, what is a quantum number? Quantum numbers designate specific shells, subshells, orbitals, and spins of electron. This means that they describe completely characteristics of an electron in an atom. There are total 4 quantum numbers. The first one is the principal quantum number. The symbol of principal quantum number is N. Is also known as energy level or shell. The energy level called by Bohr, and the orbit that was called by Rutherford and other scientists. This is actually the principal quantum number. And then we have secondary quantum number. Secondary quantum number is actually subshell of an atom. Secondary quantum number has a symbol of L, small letter of English, L. Actually, it's a subshell. And the third one is a magnetic quantum number. The symbol of magnetic quantum number is ML, small letter of English, and it shows the orbitals that are present inside a subshell. And the fourth one is spin quantum number. Spin quantum number has a symbol of M, S, and it shows the spin of electron. There are 2 kinds of spin, upward spin and downward spin. Let me show you in a diagram. Okay, students, let's consider this. This is the nucleus of an atom. It is a nucleus. And these red ones show us the principal quantum number or the shell. I told you that what's the symbol of principal quantum number? That was N. And its value starts from 1. N is equal to 1. So what's the next one? Over here n will be equal to 2, and over here n will be equal to 3. Actually, this principal quantum number describes the most probable distance of an electron from the nucleus. The larger the number n is, the farther the electron from the nucleus. So it can take the integral value of 1, 2, 3 until 7. Let's come to the next one. We have a subshell over here. This was known as secondary quantum number. As I told you that they have an integral value of their value is n minus 1, which means that if we write 1 over here, something like this. Let me first of all name these subshells. The first subshell is known as S, S and S. The second subshell is P, P. What's the third subshell? It is D. Let's know the value of S. As I told you that over here, L is n minus 1. So for the S, what is n? It is 1. The first shell has S. So for S, we will have n minus 1, 1 minus 1. That will equal to 0. So the value of S is equal to 0. Let's go for the P. So all S's have 0 value. This value is 0. And let's go for the P. For P again, n minus 1. So we will see that P starts in the second principal quantum number. So the value of n is over here 2. 2 minus 1 is equal to 1. So the value of P will be 1 in all principal quantum numbers. Let's go for the D. Again n minus 1. So we know that D starts in the third principal quantum number or the third energy level. So the value of n is 3. 3 minus 1 is equal to 2. So the value of D is 2. These are the subshell. Now let's go for we have finished principal quantum number, secondary quantum number, and let's go for the orbital. The symbol of orbital is ml. How can we find how many orbitals are present in each subshell? Over here I have written the numbers of orbital. Actually, to find the number of orbitals, it depends on the interval ranging from minus L to plus L. So it can be 0, a negative integer, or a positive integer. Let's find the for this one, for S, 0. How many orbitals are present in subshell S? ml. For 0, if you write from negative integer to positive integer, 0, only 0. So there's only one orbital. Let's go for the P. How many orbitals do we have? P. ml for the P is equal to, it's ranging from minus L to plus L. So minus 1, 0, plus 1. How many orbitals we do have? 1, 2, 3. Let's go for the D. I told you minus L to plus L. So it starts from minus 2 to plus 2. Interval ranging from minus 2 to plus 2. Minus 2, minus 1, 0, plus 1, and plus 2. How many orbitals do we have? 1, 2, 3, 4, 5. Okay, this was about the orbital or the magnetic quantum number. The last one is spin quantum number. The spin quantum number doesn't depends on any other of the quantum numbers. There are only two kinds of spin: upward spin and downward spin. If the spin of the electron is upward, it's known as clockwise. If the spin of electron is downward, it's known as anti-clockwise. And if it's upward, it will take the value of plus 1 by 2, and if it's downward, it will take the value of minus 1 by 2. So there are only two values, plus minus 1 by 2. So we can write like this: one electron upward and other electron downward. This way we can fill the electron until the last orbital. Spin up, spin down, spin up, spin up, spin up, and spin down, spin down, spin down. Again, spin up, spin down, spin up, spin up, spin up, down, down, and down. Again here, spin up, spin up, spin up, spin up, upward spin, downward spin,
downward spin, and downward spin. Students, you have studied how many electrons are present in each orbit in your previous classes, and over here we can also prove that how many electrons are present in each orbit or each energy level or each shell. You have studied that in the first shell we have only 2 electrons. Now you can see over here there are only 2 electrons in the first shell, first principal quantum number, and you have studied that there are 8 electrons in the second shell. Now you can see over here there are 8 electrons in the second shell, so we have proved it. And you have studied that there are 18 electrons in the third shell, so you can count the electrons over here. There are 18 electrons in the third shell. So students, this one's the explanation of the quantum numbers. I hope you have learned it, or you can again pause the video and again start it from the beginning to learn it in a better way.
Well, students, as we have learned about for quantum numbers, I've told you about the orbitals, that they were kind of small tiny boxes, but they are not actually like this. Orbitals are present inside the subshell. Let me show you the shapes of the orbitals. The s orbital that's present inside the s subshell has a kind of spherical shape. Okay, these are 3D shapes, not 2D shapes. And there was only 1 orbital in the s subshell. And for the p subshell, there were 3 orbitals. Each of them has a shape something like this. And for the d subshell, there were 5 orbitals. We have found it from the interarranging minus L to plus L. Yes, minus, what was the value of d? It was 2, minus 2, plus, minus 1, 0, plus 1, and plus 2. There were 5 orbitals in the d subshell. So they have a shape something like this. In the f subshell, there were 7 orbitals. Each of them has a shape like this. Okay, students, hope today's lesson was interesting and you have learned something new. If you have any question or suggestion, write in the comment section below, and please don't forget to give a thumbs up. See you next time. Goodbye.